Okay, so as in the last video, we have calculated the mass of the carbon dioxide which was produced by the reaction in which methane was burned in the presence of oxygen and carbon dioxide plus water was produced, and they ask us for the mass of the carbon dioxide, right? So what we did for calculating the mass of the carbon dioxide, they have already given us the mass of the methane, right, in the question. So the mass is already given in the question. So we know that how do we solve something? We solve everything with the mole concept. Means initially we need to find the number of moles. Now the mass was given, right? We need to calculate the mole of it. We know the formula. Number of mole is equal to given mass per molar mass, and we need to find the mole of it. So given mass was 16 and the molar mass of methane was 16 too. So 16 divided by 16, we got the number of mole that was equal to 1. Now we know that if we are using 1 mole of methane, that was of course going to produce the 1 mole of carbon dioxide as well, right? So here we got our mole. We know the molar mass of carbon dioxide as well. They have asked us about the mass of the carbon dioxide, right? So number of mole is equal to given mass per molar mass. Number of mole we already know, that is equal to 1, and molar mass of carbon dioxide is 44. So 44 will multiply here. When we go there, it will be it's dividing here. When we go there, it will be multiplied, and when we will multiply 1, the number of mole, with the molar mass of carbon dioxide, that is 44 gram, we're gonna get the given mass of the carbon dioxide, that will be equal to 44 gram. Right? In today's video, we are going to solve another question so that we can have a grip on solving for the number of moles, volume, or you can say mass, or the given particles in the chemical equation, right? So let me write the question here. So basically the question is, find the volume of carbon dioxide produced when 50 grams of calcium carbonate is heated. So find the volume of carbon dioxide produced when 50 grams of calcium carbonate CaCO3 is the calcium carbonate, right, is heated, right? Means this is a thermal reaction, right? So here the equation we have COC3 is heated, right? It is heated. What we're going to produce will be calcium oxide plus carbon dioxide, right? So now see, I have already taught you what is the first step to find something which is being asked in the question. We need to balance the equation first, right? That is very first step we need to solve. So here we need to see, is the given equation balanced or not? Let's see. Calcium carbonate is heated, thus calcium oxide plus carbon dioxide is produced, right? So see the calcium on the reactant side, that is 1. On the product side as well, calcium is 1. Means calcium is balanced. Now come towards the carbon. Carbon is 1 here, and again on the product side we have carbon 1. Again carbon is balanced as well. Come towards oxygen. Oxygen are 3 on the reactant side. However, on the product side, 1 plus 2, we have 3. Means oxygen are 3 as well on the reactant as well as the product side. Calcium is 1 on the reactant as well as on the product side. Carbon is 1 on the reactant as well as on the product side. Oxygens are 3 on the reactant side as well as on the product side, right? Now we need to understand the question first. Find the volume of carbon dioxide. We need to find the volume of this carbon dioxide, right? we need to find the volume of this carbon dioxide produced when 50 gram of calcium carbonate is heated. Means the given mass for calcium carbonate is given mass for calcium carbonate is 50, right? So initially I have taught you, for finding something you need to find or you need to calculate the number of moles first. Now how you'll be calculating the number of moles? Since as you can see the mass is already given in the question and you know the molar mass of calcium carbonate as well, right? So by placing given mass or by taking a ratio of the given mass per molar mass, you can have actually number of moles, right? So let's write the formula here. Number of moles is equal to given mass per molar mass, right? Given mass per molar mass. Given mass is already given in the question, right? And that is 50 gram. So let's put this 50 gram in this formula, right? So let me change the color of it. N is equal to, instead of given mass you can write actually 50 gram. So 50 gram in the numerator. Now what is the molar mass of the calcium carbonate? Let's find that, right? So we know that calcium carbonate, the mass of the calcium is what? It is 40 plus the mass of the carbon is 12 plus the mass of the one atom of oxygen is 16 into, there are 3 atoms of oxygen, right? So 16 will be multiplied by the 3. So 40 plus 12 is actually 52 and 16 into 3 is 48. Wait, 40 plus 12, 16 into 3 is 48. When we add these, 8 plus 2 is actually 0, 1 up, 5, 6 and 6 plus 4 is 10. So 100 gram is basically the molar mass of calcium carbonate, right? Let's put this in the denominator. 100 gram, right? So gram cancel, 0 0 cancel, 5 1s are, 5 2s are, is actually 1 upon 2 and 1 upon 2 is equal to 0.5, right? Half. 0.5. Now we have basically calculated the number of moles. Now we need to calculate the volume of the carbon dioxide, right? Now here is basically we have 1 mole, right? So if there is a 1 mole, there is a 1 mole of it as well, the coefficient, right? So if there are 0.5 moles of calcium carbonate is heated, so of course 0.5 mole of carbon dioxide will be produced as well in the product side, right? So 0.5 mole. Now we can actually find the volume of it, right? Because we know the formula in which we use the volume as well. Number of mole is equal to given volume per molar volume. By this formula we can easily calculate the volume of it, right? So the formula we are going to use here will be number of mole is equal to given volume right, per molar volume. And we know that molar volume of any gas at STP is equal to 22.4 dm cube or 22.4 liter, right? So number of mole we have already known, right? So number of mole is equal to 0.5. We are calculating actually the given volume of it. So let given volume be x first. Molar volume of any gas at STP is 22.4 dm cube or 22.4 liter. Now is 22.4 is dividing here, right? When it will go there, it will be multiplied. So x is equal to 0.5 into 22.4 liter, means half multiplied by 22.4, this value will be reduced to the half, right? And that will be equal to 11.2 liter or 11.2 decimeter cube, or x is equal to 11.2 decimeter cube. So actually we have now calculated the volume as well. How did we calculate? Since we know that for finding something we need to calculate the number of moles first. If there is something given in the question, we need to use that to find the number of mole. And here in the question, the given mass was already given, right? That was equal to basically 50 gram. 50 gram of calcium carbonate was given, and we were supposed to calculate the volume of the carbon dioxide. So we just used this given mass and we divided this given mass by the molar mass to calculate the number of mole. When we divided 50 by the molar mass of calcium carbonate, and that is equal to 100, 50 divided by 100 is half, 0.5, right? So here we got to know that the number of moles which are used here of the calcium carbonate is 0.5. So if we have used 0.5 moles of calcium carbonate, of course there would be the production of 0.5 moles of carbon dioxide as well in the product side. So there we got moles as well, 0.5. Now we need to calculate the volume of it. We know the formula, number of mole is equal to given volume per molar volume, and number of mole we already calculated. We just place this here, 0.5 is equal to, we were calculating basically the given volume, that's why I just supposed given volume as x upon molar volume of any gas at STP is 22.4, that's why I wrote. Now it is dividing here, when we go there it will be multiplied, so 22.4 multiplied by half, this value would be reduced to the half, and that would be equal to 11.2 liter, right? This is how we calculate the volume of something when there is basically given the mass of something from the reactant side, right? So in the next video we're gonna solve one more question. Afterwards we're gonna start our next topic.